So let's get right into it. What is the statistical process control aiming to do? It is aiming to study variations in the engineering process, more specifically in the field of quality engineering. It is aiming to control those variations by applying logically related statistical procedures so that the process eventually behaves in what is considered a normal manner. It is also aiming to spot outliers and controlling the engineering process to maximize quality, consistency, and the normality of the data that is collected. But how is it aiming to do all that? By employing those statistical principles and procedures, the process is being statistically controlled and the causes for variation are being studied. The process is then studied to compare how that process has behaved in the past, and from those patterns we are able to predict how it will behave in the future. Considering the causes of variations, which fall under two categories: either common cause, which are everyday events that are inevitable, and assignable causes, which are drastic events that happen every once in a while that dramatically influence the pattern in your process. Here are some of the irregularities in the trends that can be spotted in control charts, which are trends where the data is moving as a whole in one direction, as you see to the right, and shifts and cycles, where shifts is the data that tends to another direction from what is predicted, and cycles, well, it's just the cyclic pattern that the data is following. So why is the statistical process control so important? First of all, the variable control charts used to identify the behavior, which are shifts, trends, and cycles of a process, can be considered a time-lapse representation of a normal distribution curve. For studying discrete data, the Poisson and binomial distribution are applicable to the study of the process and can be graphically represented by using attribute control charts. And for continuous data, you can use variable control charts resources. Here are some debates within the community that you are able to pause the video at your discretion and read. But for our example, let's suppose that we are aiming to manufacture a hydraulic suspension system for an aircraft, and we have a production line. But what are we going to study with this SPC? We're monitoring the amount of pressure the suspension can withstand at the time of the landing until it yields and is noted defective. Here we can see in our sample control chart that our data falls within the control limits, and which means that they fall within 3 standard deviations of the expected value of the pressure of the hydraulic system, but there's a lot of variance within the data points. This leads us to how to tackle your goal. At the end, statistical process control is just a tool to help the engineer monitor the process, but in our context, we would recur to implementing a routine of maintenance on the machinery used to manufacture the components would be our main approach.